get you hooked up.
All right. That's so loud. Thank you, John, for the introduction. Thank you, everyone, for making it today. Just before we start, just wanted to thank all the sponsors for making this alive and all the organizers. It's been a lot of great talks throughout the year. I enjoyed a lot of them, learned a lot, and happy to be talking today about TensorFlow 2.0. Just before we start, I just want to get a feeling of the audience. Anyone used Keras before? Just raise your hand. TensorFlow, raw TensorFlow? TensorFlow in production? Okay, awesome. So the talk is going to be divided into two parts, mainly discussing what's the difference between TensorFlow 1.x and TensorFlow 2, what it takes to go and actually change your code. The other talk is how to put 2.0 in production using estimators, the way Google has been doing it internally for a bit of a time now. In case you haven't heard, they actually migrated from 1.x to 2.0. They announced it in September 30 in TensorFlow World conference. They have been talking about it since Google Next back in March, but it was beta. TensorFlow has been, or 1.x in general, has been open sourced in September 2015. So it's four-ish years. It feels like it's been around for a long time. So if you haven't used TensorFlow before, that's awesome. If you have used TensorFlow, TensorFlow 2.0 is not going to be a problem at all. If you have used Keras, you're already using TensorFlow 2.0. A simplified conceptual diagram of what is 2.0 about. So the main motivation for 2.0 was mainly model deployment. So there were a lot of models. You can build the best model, but getting in an actual deployment was always painful. And they wanted to tackle this problem, how to go from a prototyping of model, which a lot of people do using Keras, since it's very simplified, to actually jump to right away to deployment, right? So they would divide it into a training phase and a deployment phase. So on the training side, they did a lot of work on how to read data. So TensorFlow, raw TensorFlow 1.x is a little bit painful in reading data if you have tried decoding CSVs and trying to get the stuff into actual tensors. So they have the new tf.data, which one line of code like experimental CSV, and you're able to read the data and actually put it into the estimator, so model.fit from the load data. They have introduced tf.data sets, so that's a unified hub for different data sets. They have more than around, I guess, 100-ish data set over there. They're updating it all the time. The other aspect of it in the model building, Keras estimators. So Keras is the high-level API for TensorFlow 2.0. So you actually call Keras from TensorFlow. So anything you used to do with Keras, you're doing, it's a one-to-one comparison. So you're doing it tf.keras, whatever you're doing. Once you have the estimator, it goes into the distributed strategy. So that would distribute your training among CPUs, TPUs, GPUs, whatever you want to use. And you can do tf.summary that will take you to the tensor board to visualize all this stuff. A very cool feature that they've done is standardizing the saved model. So we actually had earlier talk this year about deploying TensorFlow Lite and how to change from TensorFlow serving to TensorFlow Lite and all the protobuf changing in the models. This is actually, you have a saved model, you can go use it as a serving, you can put it in on devices with TensorFlow Lite or TensorFlow JS. With all of that, they have introduced TensorFlow Hub, which is a really easy way of transfer learning in general. So with 2 lines of codes, you can get all the models that you want, Universal Sentence Encoder, GTP2, BERT, anything that you want to deal with is right there. So before we jump into the details, anyone recognize who's this? Francois. Yeah, so he's the primary author of Keras. So he started working on it February 2015. He pushed the first version March 27th, 2015. TensorFlow was open sourced. He also has the known for exception architecture, so it's a combination between Inception and ResNet, and he has an awesome deep learning book. So TensorFlow was released in or open source in November 2015. So it actually, when he released it, it was supporting multiple backends. So it was supporting at the time Caffe and Theano. So it wasn't made for TensorFlow at the time. So what it does, it just sits on top of the computational engine as an abstraction, and the back end would do all the crunching of numbers, all the computational, and everything is done in the back end. So September 30th, Keras tweeted that they updated the new version of Keras 2.3. So this would be the last version supported with multiple backend, more specifically Theano and CNTK. And then from now on, it will be only TensorFlow, and recommendation is just to move to 2.0. So it's that kind of thing that they're pushing really hard, especially from Google. I kind of envision it as, okay, like in anyone knows what's going on in 21 days? Python 2 is not supported anymore. So it's the same. It's the same. So it is the same push that they want. It's like, okay, if most of the people are not using Python 2, at least in production environment in companies. Now everyone is pushing that it would be the same push for 2.0. So how would you create a model in Keras, right? So there is the sequential API where you just feed forward. There is no branching. You cannot do a lot of stuff. If you want to do a little bit more advanced stuff, you can use the functional API where you can have branching, and then you can do concatenation. You can do a lot of people in the autonomous vehicle. They have like LiDAR and camera data. They do data fusion. They use a lot of functional API. It will get you 95% of the time. If you are like from the researching community, you need fancy loss functions and fancy custom layers. There is model subclassing, where you define your class and you inherit from the tf.keras.model. And you define you initialize to get the super and then overwrite whatever layers that you want. And then the call function would be your actual model that gets returned. So it's been almost 40 years. There was a lot of contribution from the open source, and it was all over the place, right? So the contrib API was a lot of functions, a lot of there was a lot of duplication, a lot of abandoned packages. So probably 3 ways to do something, like get a reload. There was 3 ways of doing reload over there. So the main thing with 2.0 is trying to consolidate all of that. And contrib is no more, it's not that anymore. Everything is moved to compat.v1, which is the OnePointX history for the all the functionality of OnePointX. So if you're using anything, if you update it to 2.0 and you're using, you can still use OnePointX, but anything with tf.contrib would not be running. moving the pre-processing into the graph. So it's a big thing because let's say we're doing a text classification model. There are some pre-processing needs to be done, right? One of it is tokenizing the data. So you can, one of the things is you can pickle and dump it, and then you actually, in the serving, when you're trying to predict, you have to call that tokenizer, right? But the problem, it still will not be scalable. So it will be based on your Python functionality. It will be an HTTP request, and it will lock your CPU or GPU to get until it finishes that. But with the 2.0, we can actually move the pre-processing into the graph. So you can use the auto signature auto graph compiler, and you can get high performance on GPUs and TPUs. Easy model building. So it's way easier now. So you can use TF data to load in your data. You can use tf.keras to build your model, or there are pre-made estimators like DNN regressors. There is pre-made estimator for like wide and deep that you can log it in, and you don't have to worry about writing anything. Eager execution, it's a big thing. So OnePointX, if you wanted to debug your code, anyone had fun debugging graphs? Yeah, I see some hands over there. So you have to say with tf.eager execution and try to build up the graph, a computational graph, to be able to know what's going on. But by default, 2.0 is eager execution. You can use the TF decorator function to be able to access the benefits of the graph and the optimization over there. It uses distribution strategies, so it can get distributed on your GPUs, TPUs, and as I said, exports to one saved model. So using tf.data, it's way easier, and especially if you're having tabular data. So you have one hot encoded, or you need bucketizing some columns, or feature crossing if you're doing some wide and deep networks. It becomes very easy with tf.feature column. Most of the presentation, I try to link the documentation, and the presentation will be shared. So you can just press on the links and it will take you to the documentation right away. I try to be as much as possible consistent around the presentation. Also convenient input for in-memory data, so it's very, it works really good with NumPy and Pandas. tf.keras and building your model, right? So keras is integrated tightly with TensorFlow, so you can access TensorFlow features whenever you want. Beside that, if you're trying to use the estimator API, it's not limited to deep learning models. You can use some other models. So if you're using XGBoost or Random Forest, you can use the TF Estimator API. The nice thing of this, if you're in a company, you want to standardize things, and standardizing the way that you deploy the models is one of those things. So if you're onboarding people or just trying to have one specific way of doing it. One of the things that I think it's not used a lot or not utilized by people, TensorFlow Hub. It's a great way if you don't want to build, if you don't have enough data or you don't want to build a model from scratch, using TensorFlow Hub, just reading that URL and putting it in the embedding matrix if it's NLP, or you can, it has a lot of computer vision pre-trained models as well. TF function. So as we said, it is eager execution by default, right? But you can use the decorator, the tf.function decorator on top of your function to run your optimized graph. So it still has all the functionality of OnePointX, but it actually, the control flow is way more simplified. So you might find the graph a little bit different, but it's for optimal performance in that essence. As an example, so if I have a dummy function like tf.add, and I have a scalar, vector, and a matrix, and I pass it to these functions, what it will do, since I have the tf.function decorator over there, it will create 3 different graphs. So if you take out the tf.function, it will run eager execution right away. Distribution strategy. So when we're building ML models, it's either we have too much data, or there is a lot of data that you need a lot of computation for, or you have big models, right? So, you know, universal centers and cooler is like 1 gigabyte or something of memory. The distribution strategy, what we'll do, it's we'll utilize your CPUs, GPUs, TPUs. You can use single node or multi-node, or actually also use TPU pods for that. 99% of the time, that will get you there. If you need to do special things with on-prem, you can use Kubernetes clusters. There's a lot of templates to deploy on training, and that will take you the last step. But 99% of the time, the distribution strategy API will deliver that. Export to save models, standardization, right? Who doesn't like standardization? So you can export the model to TensorFlow serving, TensorFlow Lite, TensorFlow GS. You can actually export it to TensorFlow Hub. So internally within your company, you can have a pre-trained model that you can post it on TensorFlow and have access to who have, like limit the access to people in your company. So that's for reproducibility within the teams in the company. It's very good. TensorFlow datasets. So most of the time when anyone is building a model, they're actually not using the data. They're using fake data just to make sure the workflow is working and everything is working good. And then they would go plug in their data. There would be some hyperparameter tuning that you need to do. But most of the people try with easy data, make sure the thing is working, and then plug in your data. So tf.datasets has over 100 datasets. It has stuff in datasets in audio, images, structured data, text, translation, video data that you can call as simple as one line. So if you look over here, so you just import TensorFlow as TFDS, TensorFlow dataset, and then you say tfds.load, you put in the name of the data that you want. Can you see it? A little bit. So you just load the tfds.load, you name the name of the data that you want to get, and you specify if you want to split it for training, testing, and then from this point you have it as a Python variable, right? So you can shuffle it, you can batch it, you can prefetch it, you can loop over it to get, so dataset.take will get you like the first, .take one will get you the first instance of the data. So you can put it in variables and image and label, and then you can do whatever you want from that point. Let's see. So I guess everyone is excited right now, right? If you haven't used TF1, you probably don't appreciate all the stuff that's done, but that's still good. You're just jumping on a very easy way to build models. But if you have code in OnePointX and you need to migrate it, it would have been really shame on TensorFlow if you haven't done an automatic upgrade script. So they did an automatic upgrade script. So you just run the script. I don't know, but I used to work a little bit in chemistry, and there was a lot of code in Fortran. And the reason no one moved away from it is there was no easy way in converting it. So thanks to TensorFlow, they have an automatic script to do that. The script will deal with 99% of the code, and it will make sure it moves everything. So all the contrib stuff will be converted to compat.v1. If you run the script and it's not able to do it, it will tell you in the logs, hey, in line 390, you want to go and fix this. So you might have to do a little bit of manual manipulation over there. So main thing is to make sure to remove all the contrib symbols because it doesn't exist anymore. You want to switch your code to Keras code, so more object-oriented. So that means have all the fun stuff that you used to do in TensorFlow 1, make sure to do it the easy way in TensorFlow. You want to use as much as possible tf.keras or the estimator APIs. and not implement your training loop. The less that you have to do, the less problem that you have to deal with. Because with the training loop, you need to be aware of regularization losses and stuff for batch normalization that gets in training, not testing, and some stuff like that. There is no sessions anymore. There is no collections. So if you used to do with tf.session and session.run, there is nothing of that, which is so cool. In general, it just takes you a fewer line of codes. Remember that most of the time the code is read rather than written. So you write the code, a lot of people read it after that. So the fewer the line, it's better. It also increases the clarity and simplicity. So you don't have to track the variable scopes. You don't have to go, oh, is it looking at this scope or that scope? And it just reduces the confusion over there. Easier debugging, so you have eager execution. So the debugging is way easier in that case. So what you do is just run the upgrade script. This will take you 99% of the way. It will not be 2.0 idiomatic, so you'll have a lot of tf.compat.v1, which is all the OnePointX API migrated to. So if you want to make sure it's idiomatic, it's looking good, you might want to go in and change stuff yourself. With that said, there are some top-level behavior changes, right? So if you're using tf.compat.disable v2 behavior, there are still some global behaviors that need to be addressed. One of them is eager execution. So if you used to do with tf.eager and execute, you need to deal with that. Resource variables, there is no more resource variables anymore. Tensor shape. So if you needed to get a tensor shape, you would say tensor shape at the 0.value. This is not the case anymore. You just say tensorflow.shape or tf.shape at the 0. Control flow, the control flow is way more simplified, so you might see some behavior changes in the graph, but it's more for simplification and optimization. With eager execution, if you have any tf.graph, you want to make sure you put it in the context of .asDefault, otherwise it will not run. As I said, for tensor shape, this used to be the way that you get a TensorFlow t.shape at the 0.value. Now this is more Pythonic, just t.shape at the 0. And you can see more examples in this link. Control flow, as I said, it's way more simplified now, but it produces the same result, but might be a little bit different graph representation. So how to make your code 2.0 native, right? First of all, you want to make sure you get all the v1 sessions run calls away. So these are, you put, instead of them, Python variables, so sessions are gone. You want to use Python to track objects and losses. So if there is no placeholders anymore, so you just define a Python object to track those variables and losses. Upgrade your training loop. So as I said, if you can use the model.fit, that's awesome. Don't implement the training loop from scratch. You want to also upgrade your pipeline, your input pipeline. So that means using tf.data. And migrate off compat.v1. So compat is, as I said, is the API for OnePointX migration. So if you want to make it native, you want to do that. So how to track variables, right? So if you used to do the get variables, there is no get variable in 2.x. It's only tf.variable now. So the variable scope would be on different levels. So the lowest level that you can find the variable scope is in the layer level. The higher level is going to be in the Keras model level, and the highest level is going to be in the module. Upgrading your training loop using the model.fit, that would save you a lot of time, and you don't have to worry about regularization losses because it automatically does this and the training true argument in calling the model. As I said, the input pipeline, tf.data, so you read the data and you pass it directly to the dot fit. So it's as simple as that. And you can iterate directly with standard Python through the data set, as we've seen before. So the migration of the V1, right? So the script might get you to a V1, but if you want to put it in native 2.0, some stuff it won't get. So v1.org.max, you want to change it to tf.org.max. And these kind of small stuff, just to make sure the code is consistent along the way. I don't know if you'll able to see this, but I'll try my best. So over here, I tried most of the time to actually type in the code, so you can actually copy and paste it. The presentation will be shared on Slack, so you can grab it from there. If you use Google Colab, you can actually make a nice comparison. There is a magic function that tells it what you can change from one cell to another, what version you're using. I believe the last version for one was 1.15. Correct me if wrong. I think it's 1.15. So you use 1.15. So you, oh man, I can't see that. So over here on your left is the TensorFlow 1 code. On your right is the TensorFlow 2. As you see, it's way less line, way more Pythonic, and way easier to see what's going on. Here we go. So over here, you define the variable scope of matmul, and you have to define the get variable w. So when you pass it, you have to pass the regularization into the definition of the scope variable. If you look at the 2.0 code, you just define a tf.variable, which is a Python function, w and b, and then you create a forward function that it's just wx times v. So over here, we're just doing a forward pass, and it's as simple as just calling the regularizer function, and that will do the whole thing. You can see there is a decorator, a tf.function decorator on top, so that will take all advantage of the graph and optimization that you need to do. So as I said, the variables are local in Python. The forward function is still defined in the calculation. There is no session.run anymore. Optional decorator tf.function and regularization collected manually, and there is no sessions or placeholders. Model-based TF layers, right? So if you used to use variable scope, there is no variable scope anymore, which is, you don't have to worry about, oh, I'm in this scope, I'm in that scope, and you don't have to define the reuse variables as well. So over here, what you want to do is there is no tf.variable. So in OnePointX, you have to define the tf.variable scope. You pass in your function. One thing to notice is, like for example, if you're doing dropout, you have to specify training equal training. Same thing with batch normalization. So batch normalization, it's a covariance shift. There is a scaling and there is a shift parameters that gets learned through the training, but it gets applied to the testing. So it's a variable that's only in the training. Same thing with dropouts, right? So you drop out some of the neurons, but when you're testing, you're just multiplying by the factor that you dropped out through overall the neurons. On the 2.0, you just use the sequential model. It's the same thing. I use the functional on the left, but it's just a forward pass. So using sequential, and then from that fitting into the data. So the main thing is you can do just a simple stack of layers with the sequential layer. And the model automatically tracks all the variables, all the regularization losses. You don't have to worry about that. Conversion is one-to-one. So it's on your left, it's tf.layers. On your right, it's tf.keras.layers. So the same thing, it's the same code, it's one-to-one conversion in that case. If you're doing mixed variables and mixed layers, it comes a little bit tricky over here. So what you used to do is you define the variable scope, and then you got that variable. You're gonna tell me, oh, the code on the right is way more than the left. Well, we're just doing a model subclassing here. So you're inheriting from the tf.cares.layer.layer. And you're defining your model in the build function or your variables in the build function, and you're doing the call function with the tf.craft decorator. So over here, just subclassing, there is no automatic control dependencies, and it's in eager mode, and you can wrap it with the tf.function. If you still can't give up OnePointX, I'm sure everyone is very happy, but you can actually still run the OnePointX code. You just import compat v1stf and you disable v2 behavior. However, you'll not gain any of the benefits and advantage of improvement made by TensorFlow 2.0, which is going to be sad. So over here, I'm just highlighting how easy it is to load the data. I know it might be a little bit small, but you can check it out later. On the left, you used to have all this big function to decode the CSV. On your right, it's just one function with a couple of parameters, and you load the data set from that point. Training loops, so you don't have to define the training loop. Model.fit will get you there. Will get you there 99% of the time. Unless you're doing research, you want super fancy stuff, go back and define your training loop. Beside that, please do not do that. It's way less mistakes if you do not go that route. I'll switch gears a little bit more into actual production code, which I think most of the people are excited about. But before jumping into that point, just defining a couple of things, right? In an infrastructure of an ML, there is frameworks, there are pipelines, and there are platforms. So framework might be one of the stuff that you're using, TF 2.0. You can use PyTorch, you can use CNTK, whatever framework you want. Over here, we're using 2.0, so that's why I mentioned over here. Pipelines, we're not going to talk a lot about it. Actually, we're not going to talk at all about it. But it's the whole production-ready pipeline. So from data engineering to training to serving, things you can look into is TF Extend. Another interesting thing that I'm really excited about is Kubeflow. Very, very interesting way of deploying models. Airflow is DAGs, built on DAGs. So I guess we use it a lot in pre-processing and analytics warehouse to build out the analytics warehouse with more structured data. Platform, so platform, something to manage your models, right? So you need to retrain the models. Sometimes you need to do hyperparameter tuning. Sometimes a big problem that we have, I don't know if anyone agrees, is model versioning. I mean, raise your hand if you had that problem. Yeah, so it's a little bit tricky to deal with, and some of these platforms provide really neat way of dealing with the model versioning. So a little bit of detour, right? So if we want to go like the easiest way of deploying a model, right? So we're gonna load the model, we're gonna have a Flask app, and then we're gonna get the request, get the text from the request, do the pre-processing that we need to do for the text, and then predict, and then return the JSON response there, right? So why is this insufficient, right? So one of the things is there is no consistent API. So every time you're deploying a model with a Flask app, you have to do a specialized Flask app for that one. It's not consistent. There is no payload, so it's using HTTP request, right? So every time it's getting an instance, it's locking your CPU, GPU. There is no parallelization. There is no distribution strategy. In inference, there is no some of the cool stuff that you can use in TensorFlow. Model versioning, it's a big mess over there. Where are you going to save it? What are the comments? How are you going to know what hyperparameters you used? It doesn't support media batching. And for large models, it's a big problem. So when you're loading the model and like universal sentence encoder is more than 1 gig, right? So it becomes a big problem. On the other hand, TensorFlow estimator is a good way to rebound off that, right? So they use protobuf in saving their models. Protobuf goes to byte 32, so it can go up to around 2 gigabytes for the model. But TensorFlow is just, estimator is just a high-level API that encapsulates your training, evaluation, prediction, and actually serving. So the estimators are actually been used and battled in internally in Google. So this is the way that they deploy their model internally. And they open sourced, I think, a couple of years ago. So you can either use a pre-made estimator. So we talked before about the DNN regressor. You can use some of the pre-made ones over there, or you can create your own custom estimator. You can run it on your local host or a distributed multi-server environment without changing anything in your code. So it's just in your, when you're in your bash script, you just change from job submit training to local. So you test all your code locally, make sure that it runs before you submit a job to the cloud, because it takes maybe 5-10 minutes to spin up the machines and all this stuff, and you don't want to be wasting time. And it's like, oh, you have a typo in line 399. That's always not too much fun to deal with. But in general, it provides a distributed training loop that controls how the data is loaded, and it handles exceptions, create checkpoints, saves summaries for TensorBoard. So we talked about the first two. Now we're going to talk about the third one, which is how to do a production-ready AIM on one of these platforms. I'm going to go with GCP because I'm a little bit biased. So it's as simple as submitting a job like this. So you define what's your output directory, your job ID. You just make sure you delete all the files if there is already files in your bucket on GCP. You have to point it to where is the Docker image. Don't worry too much about it. That means that you have to build a Docker container and then get the image uploaded to GCR. But don't worry too much about it. I think in a month or two, it's going to be automatic, so you don't have to define it. TensorFlow 1, actually, you don't have to define the Docker image. But I think that all the teams are still catching up with the deployments. So the job is like you have gCloud AI platform. They just changed it this year from ML engine to AI platform. And what you say is job submit training. So over here, if you want to run locally, you just say local instead job submit training, right? So you define your job ID and the parameters. What is your staging bucket? What is the region and the module name? So the module name and the package path is where all your code is going to lie. So what you're doing is you're having a package, a Python package that you submit to the cloud, and the over here trainer.task is where the module name is, and that would be the path for it. We're gonna look in details on what is this. You also pointed to where is your image, Docker image, and you specify what machines you want to use and what tier do you want to use. The other part of the variables over there is the model specific arguments. So you specify for the model where is the output directory, you specify where is your training file, where is your evaluation file, and other if you have any parser or argument parsers that you need to do. So how does the module look like, right? So if you look at the tree, main thing if you want to look at the text class model, so there is a setup.py file that has all the packages that is in this package. The trainer has a couple of files. The main orchestra is in the model.py, has all the load your data, download your data, and pre-process and all the training and evaluation. Task.py is going to be your argument parser. and your CSVs are over here locally because I was testing locally before going on the cloud. The IPYNB is where I'm running all of these bash cells. So setup.py, one thing to, pretty standard setup. One thing just to notice, your request should be 2.19.1. That's for Python GCS client. Otherwise, it's gonna tell you error. The task.py is where you have your argument parser. One other thing I forgot to mention, if we go back to the gcloud, the job over here. So you can submit a hyperparameter tuning job that you specify in the argument parser. So you specify that I want to do a hyperparameter for different numbers of neurons, different number of dropouts, different numbers of layers. So you specify that you're doing jobs hyperparameter, and you specify that in the task.py. So imagine that you're doing the hyperparameter on deep neural networks, and it's all distributed on the cloud. It's way faster, and it will get your results super fast. Get back. All right, so the model.py tells you how to download and load the data. You define the input function in it. You define the actual model. So what is the actual model? How many layers, branching, all the fun stuff is going to be in the actual model. You define the serving function. So when you have new data to be predicted, you need to have tf.variables as a placeholder instead of the placeholder. And you define the train and evaluate function where the training loop, if you're using model.fit, then it's defined in here. So we discussed everything about how the module look like, how to train the module. Now we have a model that's dumped into one of the GCS buckets. So how to actually deploy this, right? So first of all, you need to define what's the model name, what is the version. So if this is version 1, we're just going from scratch. And you need to define the location. So the location is where after the training job, the model got saved. And to deploy it, you just AI platform models create, and you define the model name and what region do you want in. And to put different versions, you say AI platform version create, the model version, and the model name. So where does the model get saved, right? So over here you can see different kind of models updated. It tells you, if you actually press on the models, you can have different, if you have already put in notes of what is this model about, what did you change, what was going on. They have a beta evaluation. So what this will do is very similar to Kubeflow evaluation. Have anyone played with Kubeflow? Okay, so Kubeflow evaluation, what we'll do, or TensorFlow evaluation, what we'll do is we'll take 2 different models. You can define 2, 3, 4, and it will get you comparisons between them. So it will tell you what was the hyperparameters in it, what was the model losses. It's kind of like a summarized TensorBoard view, but a comparison between parameters. It's still in the beta, not great, but if you're using Kubeflow, it's way better on Kubeflow. So how do you do predictions? So over now, you have a model that's, now it's a REST API. You can actually have a gRPC endpoint, but this one is a REST API. So what you want to do, the nice thing is automatically scales, right? So if you have a lot of streaming data, it will spin up workers to keep up the work. But if you have a request, you just want to make sure it's a JSON format, and then you authenticate. And then what you do is you just get a response with the API project and your authentication for that specific model. So you need to point it to the model. You need to specify what version. If you didn't specify the version, it will take the default version. So you see one of them is default. So if you have not specified what version do you want over here, so for example, it says API equal discovery build, M1 V1. So if you haven't defined V1, it will automatically go to the default. So what if you're not if you're working with non-TensorFlow models, right? So there is Onyx, Open Neural Network Exchange format. They have their own runtime engine, and it does support PyTorch models for deployment. Stuff that we haven't talked about, TFX or TFX10, pretty cool way of having the pipeline. Kubeflow, which I'm really excited about. I'm trying to get a POC in my company to actually see how's that going, taking one of the models that we have. It makes everything easier. So everything is like an environment it's built on Kubernetes. So everything is containerized, and all your data scientists, and they can spin up machines, different kind of machines, and they can kill it right away, but they don't lose all the data inside. They can automatically upgrade if they're running some prototyping locally, so they can have higher machines for small time and then kill it, but they don't lose the code. And it goes all the way from the data engineering aspect to the actual serving. So they have Kubeflow serving, which is very similar to TensorFlow serving. Airflow is another great tool. Uses DAGs to perform its calculations. BigQuery ML, anyone heard about it? Awesome. So GCP has BigQuery for querying the structured data, right? So you save the data over there, you can query it through BigQuery. And BigQuery ML is you can write machine learning models using SQL. Of course, it doesn't have the benefit of hyperparameter, it's not optimized, but you can write a SQL statement that will get you a linear regression, and it will do it right off the bat. It will deal with all the train test splits. It will do the hash functions if you're splitting on one column and make sure you want to get a representative sample. It will do a lot of cool stuff right off the bat. Of course, it's not a great way, but it's a really quick, dirty way to get started with just if you want to know if it's doable or no. It will get you like a baseline right away. I know I've been, go ahead.
Yeah, I have a question for you.
Sure.
So you mentioned before that you can do the pre-processing within the graph. Something like a tokenizer and the like. Up here you have Airflow. Do you know if you're able to take a ETL type DAG and then basically insert it into the pre-processing step within one of these pipelines to make that a much smoother process? So like right now, these are pretty separate processes, but the fact that they're actually incorporating the tokenizer within the pipeline is pretty interesting. Do you know if that's pretty seamless to go from Airflow in terms of ETL to the pre-processing step within the pipeline?
Yeah, actually it is. So you can use Airflow to do some of pre-processing and then go directly to the serving from that point. It's actually even another level in that. You can have a hybrid between Airflow and Kubeflow. So you can have some of the processes running in Airflow, and they're integrating together to they just handing off. You don't have to worry about any network credentials or anything. So they're trying to integrate tightly with all the components of Estimator, Extend, and Airflow. And also, one thing that I didn't mention over here is TensorFlow Enterprise. So they just released it, I think, a month ago, which is another level of TFX, but makes everything way easier. Something like a UI instead of writing code, but you have to pay for this. I know I've been going 100 miles per hour, but I had 60-something slides that I wanted to get through and make sure I know people have obligations and need to leave. But I want to thank you so much. This is my contact if you have any questions. I work at GroupBuy. It's an e-commerce company, and we have a lot of positions open for hiring. So if you're interested, you can chat with me, and thank you. If there is any questions, I'm more than happy to take them. Yes?
So, I actually migrated
Yeah, that's a good question. So the beta, so I have a couple of friends who work actually at the TensorFlow product in Google, and they were pushing so hard back in March to actually use it, the beta version. And I didn't want to use it because I didn't want to deal with the bugs. 2.0 right now, I have not found any bugs. The only thing that was painful was setting up the Docker image because TF1 was already, you didn't have to worry about that. But I personally, I have not fallen any of the bugs yet.
Okay, so because I haven't seen some myself, but as for the image, Anaconda has installation of Tigo 2.0. However, one more thing, they do claim it to be unstable. If you look at their docs, they say 2.0 is unstable. I found it more stable than 1.4. Do you agree?
I agree.
Thank you.
Thank you. Yes. The migration that I tried was on Python files. I have not tried on notebooks. So I don't know. But production level, most of the stuff is, at least for us, is on .py files. Any other questions? Awesome. Thank you guys for being great listeners, and hope that was helpful. Yes, it will be.
So it's already on Slack. Took care of it for you. So tonight's talk was live streamed on YouTube Live. I posted the link in both meetup.com and in our Slack channel. Also the slides, the link to his slides that he was presenting up here. The link is both on meetup.com and in Slack. Thank you, Mohammed. That was a fantastic talk. Two quick things before we get out of here. One, there's a lot of pizza in the background. Not in the background, in the back. Feel free to grab some. No questions asked, just take it. Kind of over-ordered tonight. Second thing is that I forgot to mention before, after the talks, we generally go across the street to CU29. It's a cocktail bar just right over here. Generally speaking, we have about 10 people, 15 people. Great conversation. I've got to know a lot of you. Feel free, please join us. No pressure to drink, just drink water. That's fine. Just come, let's carry on this conversation. I'd really like to talk about what people are doing, deploying in production, whether that's TensorFlow or something else. I think that would be a pretty interesting conversation. So thank you again, Mohammed.